software defined. SD stands for software defined wide area network. If you take an organization, let's say this is your organization, and you got some branch organizations, your branch office in various places. Usually, to communicate between this head office and branch office 1, branch office 2, we used to depend upon the ISP to provide us the VPN tunnels. We'll have an internet connection. We will have on the MPLS connection, let's say MPLS connection, and we will also have one normal internet connection. See, this is normal internet, and this is MPLS. This is how in most of the enterprises you will find one MPLS and one normal IP. IP is normal internet. Likewise, even here also. Now, why do we need SD-WAN? To understand that, what is there when we got internet and MPLS connection, two different connection. Without SD-WAN, what people used to do is they used to do a lot of policies on this router manually. This edge router, head office edge router, there we will say if traffic is going to XYZ destination, they should take MPLS. For some other destinations, it should go via internet. See, this is what called as policy. Likewise, here also we have a lot of traffic coming to this edge device. Here in this site, branch office 1, you got two edge device, one for MPLS 1 edge, internet 1 edge. So we will write policies like what all traffic will go via MPLS 1 edge, what all traffic should go via internet. We use BGP, we use policy-based routing, we use quality of service, PBR, that's what we call PBR, policy-based routing. We need to do a lot of manual work on all these routers to achieve the load share among this MPLS and internet, to prioritize some traffic via MPLS, whereas the other traffics via internet. To do all these things, you need to write a lot of policies in this router. Everything you need to do manually. See, when you do manually, there may be misunderstanding between what you are asked to told to do and what you are doing. Listen, this is an head office. So this engineer here is telling the engineer here to write some policy. But you may say like do XYZ, but he understands like XAC. See, there's a asynchronous problem. There is a misunderstanding problem. So the engineer, the head office engineer, who is in control of all the branch office, he couldn't finish the task as he expected, because the engineers on the remote side, They really don't understand. They don't understand fully what the head office is expecting. It is not that easy for the engineer in the head office from Australia to fly to Canada. It's not that cheap. So this is one challenge that every organization which is worldwide spread is facing. Head office wants these routers to take routing decision as per the head office policy. It is the head office the one who wants to decide what packet will go through the internet, what packet will go via the MPLS. So one difficulty I told you, understanding each other is a little bit tough. See that also, various region. Head office is in Sydney, branch office is in Canada, in US. Even though all three speak English, but the pronunciations, a lot of problems are there. Secondly, configurations need to be manually done on every router on each site to match the policy, to match the requirement. Configuration need to be done manually. And if there is any need of change in the policy, the head office people should call the branch office guys and wait for them to receive the call, make them understand what you want, which is going to take a lot of time. And even if you tell them, that is not going to happen immediately. First, they have to understand what you are telling, and then they need to find a way to configure such things, a way to configure the policies. So these all are all practical difficulties that everyone is undergoing even today without SD-WAN. In short, if I need to say, SD-WAN solves all this problem. How? Whatever these routers need to decide, whatever these routers need to do, the decision is made in the head office. The configuration is done in the head office. And the configuration is going to be pushed to the branch office through the network. Problem solved. So the branch office engineers need to simply provide the cabling service, the layer 1 services. The engineers in branch office 1 and branch office 2 don't have much technical work. They should take care of the power problems, power issues, and physical cable. Only those things they need to do. Rest all will be taken care by the engineer who is in the head office. So whatever the path for some traffics that branch office 0, branch office 1 should take, everything will be configured right here itself. You do configuration here for these routers. You no need to ask someone there, or you no need to go there. You do it in the head office. And the branch offices will get the exact configuration. Branch office will follow the exact path that you wish to take. See, it's a very big advantage. It's not simple thing that what we are talking. It is going to save a lot of money, a lot of time. You no need to call someone and make them understand what need to be configured there. On behalf of all the branch officers, you can do everything in the head office. The control plane. What is control plane and data plane? Control plane is the engine that decides the path to be taken for some traffics to reach some destination. For example, routing table is one example for control plane. Routing table. Because the routing table shows the path in which the packet need to be sent to reach some destination. That is the one which controls the direction, the traffic flow. So that control plane is the control plane of these routers are governed or configured, managed from here, head office. What route should be taken is determined in the head office, not in the branch office. Head office decides and pushes the configuration for the control plane, and control plane is ready now as per the policy. Now, what is data plane? According to what the control plane needs, the data plane is the one which facilitates that. Data plane, if I need to say in a simple word, data plane is what the packet goes, the packet pass through the physical lines, not the wires. That is what data plane is. According to what the control plane says, the packets are pushed over the wire. The pushing, moving packet is taken care by data plane. Control plane is not the one which is going to push the traffic. See, you are driving a car. Your brain is the control plane. Then what is the data plane? Your hands, your legs. Can your brain itself come and drive the car? No. You need your hands and legs. Press the clutch, put the gear, press the accelerator in the other leg, slowly release the clutch. As you keep moving, you may need to change the direction by turning the steering wheel left and right. Press the accelerator, change the gear as you increase the speed. For that, you need to go to the gear, move the gear lever up and down. Use the accelerator and clutch consecutively. All these are data plane. Your brain thinks, I need to go there. For that, I need to go straight first. So your brain says, go first, go straight, and take left. That's what your brain. The brain is the control plane. According to that, what control plane told, your hands and your legs, they move to make your car to go in the direction. See, the control plane and the data plane is explained now. So here what I'm saying is, for these many days, without SD-WAN, the control plane and the data plane is local to the router. The data plane and the control plane is local to the router. On each router, we used to configure what the control plane needs to be. We need to configure on each router. We need to go to this router and configure, this router and configure. The control plane separately, we need to configure. But now it is like a satellite. Here is the satellite, vManager. Through vManager, we put what all that you want. This router needs to decide. On the head office vManager, we configure using a graphical user interface. We configure using a graphical user interface what all the remote office MPLS router needs to do. The control plane of that router is determined here in the head office. Accordingly, the router gets configured in the remote. According to what the control plane says, now if a traffic comes, it is going to push it into the MPLS tunnel. So the router is obeying to what the head office have configured. It is not configured locally. Even the configurations are put on the router locally, but it is put by the head office, not someone local putting this configuration. Right, so SD-WAN helps to have a centralized management for all the sites around the globe. A centralized management. You no need to manage each router on each site. You have a centralized management only on the head office. You decide what the branch officers need to do. And that too using a GUI, which I showed you. Yeah, it will be like this. The home page of vManage will be like this. Cisco vManage. 1 vBond, 2 vSmart, 1 vManager, 4 WAN edges. Yeah, this is how the home page will look like. And using these tabs like VPN tabs and so on, we will configure the control plane for this company. Control plane of every router. So you don't need a highly skilled technical person in this branch office. There is no need for highly skilled technical person. All the highly skilled technical person is working here. Highly skilled people. Here only layer 1 engineers are more than enough. If they need to connect to the power, make sure the power is up, cooling is there. In the data center, the physical cables are properly connected. Only that much they need to know, they need to do. There is no OSPF or BGP or MPLS. They don't do anything there. Everything will be done here and pushed. All the MPLS, all the IPsec, all the service level agreements, everything will be pushed from a centralized location to all the branch offices. This is a very big advantage. The companies will save a lot of money on this. See, they no need to hire highly skilled people. In all branch offices, only L1, L2 engineers. But again, they don't need to pay big salary to the employees, but they need to pay big money to Cisco to buy this SD-WAN. So Cisco is taking the money of those employees. So instead of paying employees, now they need to pay Cisco to buy this SD-WAN solution for the company. See, for SD-WAN, you need to buy new equipments. You cannot use the existing routers. See, currently you may be having an ASR device here. No, that won't support. You need to buy special devices. You need a WebTailer, VH, or you can buy Cisco's WH. W stands for Vantage. WebTailer was one of the company which Cisco purchased, and that's how it has become Cisco's SD-WAN. Earlier it was WebTailer's SD-WAN. So Cisco also have developed edge device. So they are decommissioning these things nowadays. They stopped selling V edges. Now they start selling WAN edges, which is Cisco's, using Cisco's operating system they have designed. So you need to do an additional purchase. The existing ASR device or switches or routers cannot help you with SD-WAN. Huge money need to be invested on buying SD-WAN solution. Now this SD-WAN comes with 4 components. One, vManager. The other one is vSmart. The other one is vBond. The last one is vManager. Oh, sorry, vEdge or WH. If it is Cisco's, it is WH. If it is WebTailer, it is vEdge. Edge is edge, that's all. If it is from Cisco, we call it as WH device. If it is WebTailer's own device, then it is vEdge. These 3 are controllers. These are software-based device. Software-based. You can install them in VMs. This is hardware. Hardware-based device. These controllers will be mostly on the head office. And there will be 1 or 2 edge device in the head office. And all the branch office will also have edge device. So in short, what I want to say is, wherever this one is kept, that is where we will be controlling the entire SD-WAN network topology. Wherever this is kept, whichever the site it is installed, that is the head office for the network. That is where from which you will be configuring. Here, for a change, what they have done is they have not kept it in a site, they have kept it in the cloud. This AWS and all there, no, Azure, AWS. So this is also another option. Instead of you keeping in your own place, so this is data center 1, branch office 1 and branch office 2. Now, instead of keeping in the cloud, you can also keep it in data center 1. Yeah, here we go. Instead of keeping this in the cloud, this they have kept in the cloud. These are the controllers. You can also keep them in one of the branch. Mm. You see, this is vManage symbol. Let me zoom it for you. This is vManage, vSmart, vBond. All these three are controllers. They are VM based software. They have kept it in the internet cloud. In this lab that we will be doing, they have kept it in the internet cloud. It can be in one of the computer here in VMs. You can create multiple VMs. One vManage, vBond, vSmart. You can have it like that. So this is vEdge, means WebTela Edge. WebTela Edge. This is cEdge. cEdge is nothing but WAN Edge, Cisco's Edge. See the symbol difference. This is also Edge device, but this is from Cisco. cEdge, Cisco's Edge. This is WebTela's Edge. Let's see the specifications. You see, iOS XE is used. That is what cEdge, XE device, CSR devices. iOS XE operating. This is Cisco's operating system, and this is WebTela's. So data plane routers are both vEdges and iOS XE, and we got controllers for routing policy vSmart, for central management and provisioning vManage, and orchestrator and facilitates the outbound and secure communication among all the SD-WAN components, vBond. See, these are the components of SD-WAN. See, with the definition they have given, it's very nice. Let me copy this, make it nicely bold and explaining. What is the job of vBond? This is what it does. Orchestrate to facilitate onboarding, not outbound, onboarding, meaning when a new WAN edge comes, when a new WAN edge wants to become a part of our SD-WAN, who is going to onboard it? Who is going to welcome it? It's the vBond. That's why it is called as bonding. Bond. vBond. Ask me question if you did not understand. Any time in the middle, you can stop me. You no need to wait for the end of the class. vBond's job is when a new device comes into SD-WAN to participate, vBond is the first person to deal with them. See, because this is over the internet worldwide. What if some attackers want to form association to your SD-WAN? Danger. In internet, anyone can try to come inside our network. So vBond is the one which is going to onboard it by thoroughly verifying whether his genuine edge that we have purchased. See, there may be many people having SD-WAN in the cloud. There will be many edge devices. You cannot interact with all edge devices. Only your WAN edge devices, your branch office edge devices, you should associate. How will your SD-WAN knows your edge device? Through the controller. Which controller? vBond. The job of vBond is to identify the right member of the SD-WAN. My SD-WAN and your SD-WAN is not same. I am doing training business. You will be doing maybe network consultant office around the globe. I have a lot of branch office. You have also got a lot of branch office. And you got SD-WAN. I also got SD-WAN. I also have my vManage. You also have your vManage. My vManage should not send the control planes to your WAN edge. No. My vManage should send it only to my edge devices. How is that possible? vBond makes it possible. vBond is the one which is going to bring all those edge devices and vSmart and vManage together by thoroughly verifying their credentials. So every device needs to go through an authentication process with a whitelist model. We'll talk about the whitelist model later. And that authentication is done by vBond. So whoever gets authenticated, they all form one SD-WAN fabric. So all my edge devices, my controller like vSmart, vManage, they all will know the credentials to use to form a group. So using those credentials, it will come to vBond. And vBond says, yes, I know you. You have given the right credentials, so I accept you in this SD-WAN fabric. That is what we call as onboarding. Onboarding. See, when you go with a proper boarding pass, you will be onboarded into the flight. Otherwise, they don't accept you inside the flight. You need to have the right boarding pass. vBond is an orchestrator to facilitate onboarding and secure communication among all SD-WAN components, meaning, what if when I give my credential to vBond, someone know it. If they know it, they will use the same credential and they will also try to onboard, which is not acceptable. So, vBond also uses a secure communication so that no spoofing, no bad guys can become member of our SD-WAN. It uses TLV. We'll talk about that later. Even IPsec is also used between the WAN edges. IPsec is used between the WAN edges, the data plane. TLVs and DTLVs are used during this onboarding process. We'll talk about those protocols a bit later. So, do you have any question on why or what is vBond? Please. Hmm. Correct. So, if WAN edge devices needs to become part of our SD-WAN, they need to go to vBond first and get authenticated. That's what you said. Yes, you're right. So not only V edges, not only the edge device, even the controllers like vSmart needs to go to vBond to get authenticated. Right. So that is why it says all SD-WAN components, not only edge device, all SD-WAN components. Yes, yes, vSmart also need to get authenticated. Even vManage will get authenticated initially, but in a slightly different manner. We'll talk about that when we go deeper. So with everyone, the vBond gets vBond will vBond with vBond only, through vBond only everything happens. In fact, vBond is the one which is going to show the way to vSmart and vManage. See, when a WAN edge comes, WAN edge will know only vBond. Edge device will know only vBond. They will not know vSmart or vManage. They will know only vBond. The edge device will come to vBond and provide the credential. Once the vBond accepts the credential, once the vBond is happy to accept the WAN edge and the fabric, now vBond will provide the information about the vSmart and the vManage. So edge devices knows about vManage and vSmart from vBond. Once the authentication is successful, vBond will provide the IP address informations of vSmart and vManage to edge device. Using that information, edge device will go to vManage and vSmart and become the part of SD-WAN. That is how you will see here. That's how you see vManage showing you how many edge devices. vManage knows that there are 4 edge devices. It knows there are 4 edge devices. How it knows? vBond provide the information about the vManage after authenticating the edge device. vBond gave the IP information about the about the vManage and vSmart. That is how this edge device has come here and got attached. No need to be manually. There is another process called whitelist model of authentication. We'll talk about that later. It will be actually pushed through vManage initially. Yeah. From vManage only, it will be pushed to vBond. So now we see here in this topology, everything that is going to control is not in any of the site. It is in the internet cloud. Fine, let us go back to these 3 more points. What is the job of vManage? Central management and provisioning system. Meaning this is where you will go and define all those policies, all those control plane of all the remote sites and local sites. The provisioning is done here. And you will also manage everything from this vManage. That's why it is central management. From the central management, you can see every branch office, all manages and vSmarts and everything from here. You can do changes to everything from vManage. What is vSmart? vSmart is also like vManager, but you won't be interacting with vSmart. Whatever you configure on vManage, vManage will provide the vSmart and vSmart is the one which is going to distribute it to all the edges. See, vSmart is coming as a mediator between vManage and those edge devices. vSmart is like a rendezvous point in multicasting. Do you know rendezvous point? Okay, vManage is like a broker. vSmart is like a broker. You want to land, you go to a broker and say, I am looking for this big land, like 5,000 square feet, and the area should be quiet and calm, and my budget is only 2 crores. Yeah, all these things you tell to the vSmart. Likewise, the landowners also go to the broker and say, hey, I have this land. If there is any party, you let me know, I'll give you commission. So now, vSmart knows which land I need to introduce to which customer. There are different type of customers. Some customer want small land, some customer want big land. Likewise, landowners, some owners selling small land, some owners selling big land. So depending on the customer, vSmart decides the owner. Okay, for this customer, this is the owner. He connects, vSmart connects them. Likewise, vSmart knows the policy that is configured in vManage, and vSmart also knows all the edge device. So it knows where to put the policy. Not every policy will be pushed to all edge. Some edge needs BGP, some edge needs OSPF. Depending on what you have configured, vSmart decides to whom the configuration need to be pushed. At last, the data plane which is going to forward the packet according to the control plane that is provided by the vSmart. This data plane, if it is from WebTel, it is vEdge. If it is from Cisco IOS XE, it is called as cEdge, or in common we call WAN edge. You can call WAN edge, in that is general term both for vEdge and cEdge. If it is Cisco device, it is cEdge. Any question on this? All right. So today we have got a very good understanding, introduction to SD-WAN, the components of SD-WAN. In coming days, we are going to see in detail how this vBond authenticates, how this WAN edge goes to the vBond, with what credential they go, all those things we are going to see. Right? We'll stop